Welcome to Vansik Maths. Remember to subscribe. Today we want to look at how to change complex numbers to polar forms. We have the first example, Z1, which is 4 plus 3i. The coefficients are positives for the real number, the imaginary part. The second one, we have negative 3 minus i4. So first of all, you have to be in the back of your mind, you need to know that in polar form, z is given by r into cos theta plus I sine theta, and we know that r is the vector which is given by the square root of x squared plus y squared, and theta shall have the tan inverse of y over x. So starting with the first example, you can just sketch. Real part is 4, imaginary is 3. So if you have this vector, then the angle is theta. Okay, if you want to get theta, you'll have the tan inverse of opposite is 3, adjacent is 4. So theta, to get theta, I shall get the tan inverse, get 36.86 degrees. Then you can also convert these degrees if you want. We know that 60 minutes is equals to 1 degrees. Equals to 1 degree. So you'll say, what about the decimal part, 0.86? If you multiply, you're going to get that your theta will be now 36 degrees. Then we have 52 minutes. Then you can find r with the square root of 4 squared plus 3 squared, so you'll get 5. This one will be 16 plus 9, 25, and you get the square root, which is 5. So now your z in polar, it will be 5 into, we have cos 36 degrees 52 minutes plus I sine 6 degrees 52 minutes. So you can have the other example whereby we have z is equals to negative 3 minus i4. So here again, sketch. The real part is negative 3, imaginary is negative 4. So you have your vector here, vector r. Then the angle should be theta from the real axis. So if you want to get theta, we are saying it is the tan inverse. Your y, we have 4, take the absolute value, divide by 3, say opposite over adjacent. So this one, when you press in your calculator, you are going to get 53 degrees. You are going to get 50 degrees and 8 minutes. So for my calculator, it gives me in that mode, but you can always, if yours gives you in degrees, you can always use 60 minutes equals to 1 degrees. Then you convert the decimal part to 8 minutes. So since this one is on the third quadrant, for the first quadrant usually the angle is theta. For the second quadrant, we subtract theta from 180. Third quadrant, since you are reading the angle from here, so you will add that angle plus 180. If it is in the fourth quadrant, we usually subtract the angle from 360. So for our case, now the argument will be 180 plus 53 degrees and 8 minutes. So we'll have 233 degrees 8 minutes. So your z in terms of polar, will be, now we have 5 into cos 233 degrees 8 minutes plus I sine 233 degrees 8 minutes. So you have to take into consideration the angle lies in which quadrant. Up to there, I hope you can get the polar form of a complex number.